Hello, and thank you for joining our talk on embracing Go for mobile DevOps. My name is Samir Moore, and I'm a senior Android engineer with the Mobile App Ops Squad, and I'm joined by Jamal Rogers, a senior iOS engineer in the Mobile App Ops Squad at the New York Times. Our team is responsible for supporting CI and creating build tools that assist all of our mobile developers with creating mobile apps at the Times. During this talk, we will be discussing the issues that we're having with our old approach with mobile DevOps, how we're going to use the Go programming language to help us develop our newest mobile DevOps tools, and some of the challenges we faced with migration. So just a little background on where we were. The New York Times supports a lot of apps. This includes our main news app for showing the New York Times articles. We have an app for cooking. We have an app for games. We also support apps for the Wirecutter and the Athletic. And all of these apps are supported on Android and iOS. The number of apps that we support is constantly growing. And what's important is that these apps are all developed independently from one another. This caused a problem with division. So we had a lot of platform division going on. This is division between Android and iOS. Both platforms are built on different CI systems. Android was on Jenkins and iOS was on Buddy Build. Since then, we've moved to Bitrise, but this caused a lot of duplication because we were working across different platforms. There was a lot of duplication in the tools that we were building, and it was hard to build common workflows that worked for both platforms. Along with the platform division, we also had an app division. So again, each app was developed independently of each other. So Android News was developed independently from Android Cooking. So this caused a lot of tools that were developed per app by different development teams. This made it hard for developers to switch between apps because they would expect tools that existed on one app to exist in the app that they're going to. Any tools that were ported over to new apps are usually copy-pasted, and this caused a lot of support issues because as time went on, these tools started to diverge from what they were. At the end, there was very little centralization, and there wasn't a really good way to share the tools that we were developing. So along with the apps, we support a lot of services. A lot of the tools that we make and workflows that we have, we need to integrate with a lot of different services, things like AWS, GitHub, Bitrise, some internal New York Times services. We continue to add services as they are needed, and we also need, and a lot of these services are used by CI in our build tools. We are also supporting a lot of different languages. At one point, there was a total of 6 languages. This included PHP, shell scripts, Python, Kotlin, JavaScript, and some early attempts at using Go. This created a lot of knowledge silos for us. Developers were working in the languages they were most familiar with, and it was hard to find developers who were familiar with all of these languages. It was hard to share the work that we did with one another because they were just developed in different languages. And it was hard to understand some of the shorthand code that exists in some of these languages, particularly in shell scripts. It promoted a lot of duplication in our languages. A tool that was written in one language would need to be copied and ported over to another language. And a lot of the things we were duplicating was boilerplate code. You can think of things like setting up communications with a third-party service like Slack or GitHub. Finally, this was a deployment nightmare for us. All these languages have different deployment instructions. So it became hard to figure out how each language works with in our different environments.
Another issue we had was with testing. We didn't have a uniform testing strategy. We had different testing strategies for different languages and different environments, and that led to less confidence in our tools because we didn't always have consistent tests to back up the code, and it was hard to tell if a change would break something unless we ran a workflow and saw the results. And this made it difficult to scale. It would be very hard to tell if something would break something and to roll out to different applications without making changes beforehand. Also, we had no consistent code standards. It's hard to develop those standards on different languages, especially with people have varying degrees of familiarity on each language. and each language has its own approach to static analysis. And also, there led to dependency management issues. We would have to install additional build tools to parse the different languages, and also to install Node, Ruby, Python, and it's also hard to reason about what was needed for an environment. Some tools would work differently on our local machines versus build machines, and our build machines versus our automation machines. Right, and so saying all that, we move forward to Go. One of the things we wanted to do is get a list of requirements we had for our new language. We wanted to unify on something modern that had community support, that had consistent distribution, distant availability on different environments. And we wanted to create a centralized library that could be used in multiple use cases. And so something that would enable that had good module management support, and that would improve our shareability. We really wanted to avoid copy paste and code, and wanted to do something that had a versioning system so we could encourage that dependency management was done simply. And so we selected Go as our primary language primarily because of the internal and external support. A lot of our teams and projects in the New York Times use Go, as well as externally, Bitrise and other partners. There's a lot of Go examples and support, and the wider Go community is full. The testing makes it easier to test code, as well as linting. It's easy to read. The language is portable. It will run on different environments and operating systems, and it's a lot easier to distribute tools. And one big thing that made it easier for us is that all of us were coming in fresh, so there was not a knowledge silo, and there was less misunderstanding about the code we were writing. And so one of the things that we liked about Go was modules. So Go modules are a collection of packages. They handle dependency management. So if you require a module, the Go built-in tools will go ahead and make sure that all of the dependencies updated based on those modules, and making sure that your system has what it needs to build and run. And also, the versioning is simple. It's based on Git and source control management. So all of our Go modules are their own Git repos, and we can create a new release just by adding a tag. In addition, Go has a big standard library and more. So here is a list of some of the standard library tools, some of the standard library packages, and enable to use those for handling things like cryptography, file input/output, and a lot of that was already set. We did not have to use third-party libraries like we have with some of our previous solutions.
So after choosing Go as our main language, we came up with this architecture. At the bottom, we have our core modules as AP Go mobile tools. And then above that are two sides of our stack, AP Bitrise steps for our custom Bitrise steps. And on the left are our standalone tools, which are basically Go applications that can run anywhere. We'll go into details about each one of these. So our core Go module is AP Go mobile tools. It consists of many packages, and each package supports its own domain. So for instance, the Slack package is responsible for communicating with Slack. NYTnet is our custom wrapper around Go's HTTP framework, and it just handles communication over HTTP. And we're constantly adding more packages as we find new things to support. The code written here is written under the assumption that can be run in any environment. So we don't assume that the code is going to run in Bitrise, or only it can run anywhere. We invested a lot into testing with the core module. All of our packages have unit tests to back them up, so we're confident that the code will run correctly in multiple environments. The static We also invested in static analysis checks, so we know all of our code is following some standard. And to do this, we use the tool called Golang CI-lint, which is a grouping of multiple Go linters, so we can configure rules for how we want our code structured and standardized. Finally, we're able to easily share the core module. We're able to version this using Git tags. So every time we make an update to this core module, it'll be given a new Git tag, and we can share it easily with other Go applications. We just specify the GitHub URL to the core Go module and specify a version tag. You can see an example of using the core module here. At the top, we have two import statements. One, they're each importing from the core module, and they're importing a specific package. One is for Datadog, and one is for Vitals. And in our main function, we create these API objects to interact with. So in the first line, we're creating an API object for Datadog, and then further down, we'll call a function on that Datadog object to send a Datadog log. So that was a core module. On top of that, we built our custom Bitrise steps. So AP Bitrise steps is a single GitHub repo with many directories. Each directory is its own Bitrise step, and each step is its own core module, Go module. And again, each of these Go modules is dependent on our core module. The steps are configurable using step.yaml, like most other Bitrise steps. And we can also leverage Bitrise's open source Go modules to assist in our development of steps. For example, Bitrise has a Go step module to help configure Go steps, Bitrise steps. So we've been using that to help us with some of the options around using step.yaml. Finally, when we develop a new step, we try to make it so that it supports multiple platforms. So it's not a step just for Android. It can work on iOS too. So that was the CI. That was the right-hand side of our stack. And then on the left-hand side, we had our custom tools. Now, these are tools that can run in a variety of environments, and they all serve different needs. So they can run on an automation server or just a person's computer. Each tool supports a different use case. So, for example, the Vitals logger is an automation tool that we have that runs once a day. It downloads metrics data for apps from the Google Play Vitals API and uploads it to Datadog so we can see all of our metrics in one place. The release manager is another example. It's a Go CLI app that runs on our release manager's computer. Basically, it allows the release manager to start and stop code freezes and to publish builds to the app stores. One advantage of using Go is that we can compile our applications into binaries that we can install in different environments. So, for example, the Vitals logger can be compiled into a binary that can run on Linux machines. The release manager can be compiled into a binary that can run on a Mac machine running Silicon. So at the end, we have this nice tech stack by modularizing and using Go modules. And it's easy to understand where our dependencies are coming from. Everything is built on top of our core module. AP Bitrise steps is mainly used for our CI needs. And the standalone tools serve a variety of use cases that we're constantly coming up with new use cases for different tools. If we discover something that is used in say a standalone tool that we think can work in one of our CI steps or vice versa, that's something that we can consider moving into our core module so we maximize how much we can share code.
One use case that we have for Slack is for Slack messages. So when we have various builds on the different projects, we want to send a Slack message to a channel or an individual to let them know that a build is ready. And we had steps to set up for this to do in several different ways in different projects. And there was inconsistencies. The messages did not necessarily all look the same, and sometimes they had slightly different formats. And when we added a new app or needed to to change the way we were sending, we would potentially have to duplicate code. And if something changed, there would be a few places we would have to update that. What we wanted to do is to make that more consistent and make it easier to version and set out. So what we did, on the next slide shows us our Slack package. We created a Slack package that was in our core Go modules that creates a message and will able to send a message to a user or a channel based on the message received. And this was centralized, and now we use that in our core step from both our standalone tools and our custom Bitrise steps, and that we created a custom Bitrise Slack step that will use this, as well as creating a configuration for templates so that we can specify a build template or a simple message template, and that way any workflow that is using this in our CI will have the same format for those Slack messages about builds. All right, so that's basically what we've done and some of the challenges we've created, the challenges we've encountered when making this transition. We'll go over. There's specifically one of the things we found some issues moving to Go in the learning curve. As I mentioned before, all of us were new to Go, and so there was a little bit differences between the previous languages we had used, such as Kotlin and Swift. For example, there is a way you're not allowed to extend classes or types in other packages where in Go, where you can do that in Swift. Also, there was an issue with our linting rules that encourage use of pointers over passing by reference, but that caused some issues with figuring out when to use pointers to avoid referencing nil or unintentionally modifying a reference. One thing that really helped is creating a dedicated Go learning time weekly as a group. So we would go ahead and share our learnings with each other in that group and share strategies.
One of the other challenges was migrating everything to Go. At first, our initial plan was to move everything to Go and remove all of our other language dependencies. We tried to do all of our tools at the same time, and this included tools that were working well. We ran into a lot of dependency issues. So as we were migrating one thing, we ran into a chain of dependencies that also had to be migrated, and this expanded the scope of the work that we originally anticipated. It's also excessive to use Go for some simple things. Like if I just wanted to create an environment variable, I don't really need to switch something to Go for that. I can use a shell script. It's okay. Maybe calling a web service and not caring about the response I get back. As another example. To fix this, we did a few things. We only migrated things that were used by all of our apps and would have high impact. So we looked for things that would benefit the most from code sharing. We also started migrating things as they were needed. So if we started work on something and it would touch one of our scripts, then maybe we consider porting that over to Go. So we wouldn't migrate things over that were working well. We just migrate them as they were being worked on. Finally, we came up with a standard stock to help us decide when to use Go versus shell script. So basically, if we were working on something complicated that involved serialization of JSON or XML, or it required calling multiple services, or it would require something that existed in the core module, that would be a good place. That would be a good example of something to use Go with. For something simple where we don't have this long chain of dependencies, or I'm not doing anything too complicated, like creating an environment variable, a simple shell script would work for something like that.
Right. So that was our journey. So in conclusion, Go provided us the ability to centralize our tools, create standards. The core library can be improved on as we go, and now we have confidence that our tools will work through testing, and we're able to innovate and iterate over our workflows. That's it. Now we'll take questions. We have one question in the chat so far. The first question is, how and where do you use Datadog as mobile tools? So for Datadog, we are using Datadog in our apps to instrument measures to analyze user experience and look at different metrics. We also are using it in our CI structure to instrument how long build times take, so we can run that locally as well as on our CI to measure if build times change over time.
Yeah, and again, the vitals logger pulls data from one source and transfers it over to Datadog, so we have everything in one place. There's another question. We see that you're using Bitrise for your company, which generally manages the entire CI/CD. And what's the reason behind using Go modules again? So Bitrise is great. They have a lot of steps, but a lot of the things that we do require something custom specifically for the New York Times. We have specific requirements around how we create our versions, how we're pulling down keys, how we're sharing secrets from our private secret store. These are things that don't exist in the open source Bitrise steps, so we had to create our own scripts to do that. And creating scripts and sharing them was becoming a little bit of a pain and hassle to figure out. So we ended up using creating our own steps to do that. And it made sense to use Go for this because the Bitrise environment supports Go out of the box.
Yeah. And I'll add in additionally too, with our centralized Go modules, we're able to sort of create consistency between the acts that we take on CI and running those similar functions locally and in our standalone tools. All right. Those seem to be all the questions we have right now. If you have questions, okay, we've got another question. Go manages dependency in Swift just like SPM. Go has a dependency manager in a similar way that the Go modules, you're able to create files called go.mod files similar to your package.swift, and that does a similar function to that, or npm and Node or other languages package management strategies. All right, I think that's all the time we have for questions. Thank you very much, and enjoy the rest of the summit.